All right, welcome back, guys. In this video, we're going to discuss the marginal analysis in business and economics. So in the sense of what we've done so far, up to 2.7, we introduced the concept of limit. Then we need limit concept to introduce the derivative concept. And so we see a little bit derivative in action through math example and graph example as well. So in this lesson, we're going to look at derivative being applied in the business and economics area. So keep in mind, these examples are classroom example, not quite realistic, but in the sense of they are application involve these example we're going to go over. But things that can be, since it's a classroom example, it's not as in-depth. It's pretty simple as far as introducing the concept of marginal. But before we get through examples, let's look at just a few notations. So let's get those out of the way. So as far as function goes, we have different functions, different theme functions for this class. Okay. So let's just go ahead and write definition. Okay. So we know that the notation C of x is referring to the function of total cost. Okay. Total cost of producing X items, so X units, right? So this cost function can be linear or nonlinear. And then we have R of X. Okay, so this is going to be the total revenue, right, of producing and selling X units or X items. And then we have the profit functions, which is capital P of X. This is the total profit. And total profit, usually to compute profit, we need the two functions, revenue and the cost. So usually we can take the revenue and subtract the cost function, and that will give us profit. Okay, so that's usually how we compute profit in general. And then we also have one function that we didn't quite go over. That was the average cost function. So if we have C of x stand for the total cost of producing X items, then C bar of X, the formula is taking total cost divided by how many units produced. That will give us the average cost per item. If X items are produced. Okay. So C bar of X stands for the average cost function. So now let's introduce marginal. Okay, so if we take the derivative of the cost function, we get C prime of X, and this is stand for the marginal cost function. And the term marginal is referring to rate of change. So this is referring to a rate of change function. So this is a rate of change function. Okay. And that means is the derivative is tell how the cost function is changing. Okay. If we take the derivative of revenue, we get R prime of X. And that is the marginal revenue function. Again, these derivative function these marginal functions are telling us how the original function C of x, R of x are behaving. Is it increasing or decreasing at a certain level of production? And we also have marginal profit. So P prime of X is R prime of X minus C prime of X. So we'll just take the derivative of this difference here, and that will give us the difference of the derivative, and that will give us the P prime of X. So P prime of X is the marginal profit function. All right. So and then if we take the derivative of the average cost function, we get C bar prime of X. So again, if C bar of x is average cost function, then c bar prime of x is the marginal average cost function. Okay, so those are notation that you want to get familiar with. So now we're going to introduce another notation in this lesson. Okay, so more definition. Okay, so if C of x stand for the total cost of producing x item, then C of x plus 1, this stand for the total cost, this notation stand for the total cost of producing x plus 1 items all together, right? So this is how we calculate the total cost if the company produced x plus 1 headphones or radios or calculators, whatever the unit we prefer to. So now if we take the total cost, producing of x plus 1 items and then subtract the total cost of producing x items, okay, this answer, this value essentially will give us, you know, the cost or the exact cost of producing the x plus 1 item or unit. Okay, so if we know the total cost of producing x item and then we also know the total cost of producing x plus 1 items, if you subtract those two values, then that will give us how much exactly cost the company to make that x plus 1 item, meaning you know, if it was you know, for example, if it was C of 11 minus C of 10, then this right here will give us the exact cost of producing the 11th item, right? Okay. All right, so those are the notation we wanted to get familiar with. At least the language. When we refer to marginal functions, we refer to the derivative functions. So now we're gonna apply this notation in our first example. Okay. All right. So the first example, we have a company manufacture fuel tanks for cars. The total weekly cost in dollars of producing X tanks is given by C of x equal to 10,000 plus 90x minus 0.05 x squared. Okay, so this equation here, this is the total cost equation. Cost for producing X tanks. Okay. All right. So part A, we want to find the marginal cost function. So that's just asking for part A. That's just asking for marginal cost function. That's just asking for C prime of X. Okay, so we're going to apply the power rule for derivative. We're going to get derivative of 10,000 is going to be 0. So this is going to be 0. And then the derivative of 90x is going to be 90. And then the derivative of negative 0.05 x squared, that's going to be 0.1 x. Okay, so that's the marginal cost function. Part B is asking for find the marginal cost function at production level of 200 tanks per week. So we're going to say marginal cost at X of 200 per week. Okay, that's going to be C prime of 200. So plug in 200 for X in the derivative function. That will give us 90 minus 0.1 times 200. And that will give us what? That will give us, let's see, that will be 2070. 90 minus 0.1 times 200. That will give us 70. Okay. All right. C, we want to interpret. So interpret the result in part B. So interpret C prime of 200 equal to $70. Meaning, what does this $70 value means? Okay, so since we plug in 200 into the marginal cost function, and the marginal cost function is the derivative function, and the derivative function is supposed to tell us the rate of change of the cost function at the current level of production. Okay, so this means that at the current level of production, current production level, okay, of 200 tanks per week, okay, at that current level of production per week, okay, the total cost, or the cost, the production cost, just do production cost, is increasing at a rate of $70 per tank. Okay, so that's what the $70 means. Okay, the derivative function evaluate at the current level of production give us $70 per tank. This means if the company is producing 200 tanks per week, at that rate, the company will have an increase in costs of $70 per additional tank produced. Meaning, if the company decides to produce 201 tanks per week, then the total cost will increase by $70. Okay, so we can do that really quick here. So we can say, all right, so let's just furthermore, let's say C of 200. So that will give us the total cost of the current production level. So let's see, we have 10,000 plus 90 times 200, and then 0.05 200 square. Let's see if we do that really quick. Let's see what we get. 1,000. So I can do this here. So 1,000 calculator. So 10,000 plus 90 times 200. I want to do 10,000 plus 90 times 200 minus 0.05, and then times 200 square. Let's go ahead and do, how do I delete this? Delete. Okay. All right. So enter. So it's at $26,000. Okay. So we're gonna say the current weekly cost is $26,000, right? So that means we can estimate that when, you know, X is 201, one more tank is produced per week, you know, we can say that, you know, total cost is approximately 26,000 plus 70, so that's $26,070 per week. So we can say that, okay? If that's what the current rate is doing, is increasing by extra $70 per tank. Now let's find that out in part D. Okay, so part D is asking for the exact cost of producing the 201st tank. So the rate of change here, this is just an estimate how much it costs for one more additional tank. D is, since we have the form, part D is going to tell us exactly how much it costs to produce one more tank, or the 201st tank. So the exact cost of producing the 201st tank. All right. So using the formula for the exact cost, there it is. This is the exact cost. Okay. We're gonna take the total cost of 201 minus the total cost of 200, and that's gonna give us the exact cost. Okay. So we have C of x plus 1 minus C of x. C of x plus 1 in this case is going to be 201. C of x is going to be 200. Okay. We've already compute the C of 200. I'm not gonna rewrite that again, but for 201 you have this here, 10,000 plus 90 times 201 minus 0.05 times 201 squared. All right, and we've already done this part up on top here. Okay, so I'm not gonna rewrite that again. 26,000. Okay, so if we plug this into a calculator and do it correctly, we should get the exact cost for producing that 201st tank. Okay, so let's do that again. Let's see, second entry. Okay, so 201. All right, let's try that. Minus 26,000. So it is costing us around 19 over 9, 69, 19 over 20. So 69.95. So it's going to cost us $69.95 for producing the 201st tank. Okay. Now I want us to compare the answer in C and D. Okay. Actually, yeah, C and D. So in C, we estimate that in C is we got, so I'm just going to go ahead and write down here. So just remarks here. Okay. So we have C prime of 200 is equal to 70. And then we have C of 201 minus C of 200. And that's 69.95. Now both values are very close. Okay. So what can we say here? We can say that the derivative, the rate of change at the 200 at the current level of production, will allow us to estimate the exact cost here. Okay, so we can make that conclusion, and it's actually, this is gonna be a theorem. Okay, so this is gonna be a theorem. Okay, this is saying that this theorem is referring to marginal costs and exact costs. Okay, and this is saying that, okay, we can take the marginal costs to approximate the exact costs. Okay, so this is marginal cost, and this is the exact cost. Okay, so this here, this is the exact cost of x plus 1 item, and then this is the marginal cost at the current level of production level x. Okay, so if we plug in the current level of production level x into the marginal cost function, that will allow us to estimate the exact cost of producing the next one. Okay, all right, and in the next example, I'm gonna show you guys that. Okay.